Hello everyone, and welcome to Jam Academy. In this problem we have a uniform chain of mass m and length L is stretched out on a smooth horizontal table. The table is smooth, that means there is no friction between the chain and the tabletop, such that a portion partially hangs over the table as shown. If the chain starts slipping when the length of the hanging segment is x, determine the acceleration of the falling chain and the tension in the chain in terms of given variables. So we know that the chain starts falling when the length of the hanging portion is x. So this will be L minus x. You see, the very first thing that we will do is to draw the free body diagram on both sections of the chain. We have section 1, which is on the tabletop, and section 2, which is hanging. So let's begin with section 1. We have the tension in the stretch chain. I'm just going to call that T. We have the weight. This is just M prime G. Now we are going to have here the normal force, which is just N. Remember that there is no friction between the chain and the table because the table is smooth. So in the exam problem, pay attention to ask yourself, is the table smooth or not? Now, if there is no word as smooth in the question, then the table is rough. So keep that in mind. On the hanging portion, we have, this will be mxg, and this will be T. Because the table is smooth, the tension in the stretch chain is the same throughout. So all we have to do next is to apply Newton's second law. So let's call this, we therefore have the summation of F along the x direction. This will be equal to mxa. So for portion 1 of the chain, we will have T equal to M prime A. Now for portion 2, you will have mxg minus T equal to mxa. Now this is equation 1 and this is equation 2. From equation 1, you can now see that T is equal to M prime A. So carefully, you can therefore just substitute this in equation 2. You have mxg minus M prime A equal to mxa, in which case mxg is equal to M prime plus mx all multiplied by A. In other words, the acceleration of the chain is going to be equal to mx divided by M prime plus mx all multiplied by g. Now, this is not the answer yet, but the reason I have circled that equation because it looks very familiar. And you understand why I say this. So the question then that we need to answer is, what is mx and what is M prime? So let's set forth to calculate that. The chain is uniform. That is important. If the chain is uniform, it means that the linear density of the chain is constant. And the linear density of the chain is lambda, which is going to be equal to mx all divided by x. This means that mx is equal to lambda x. Similarly, lambda will be equal to M prime divided by L minus x, which means that M prime is equal to lambda bracket L minus X. So these are the various masses of the various portions of the chain. Hence, we can therefore see that M prime plus Mx will be equal to lambda X plus lambda L minus lambda X. The lambda X will cancel out each other, and all of these will be equal to lambda L. Now, isn't that beautiful? Because A then simplifies to become A will become Mx, which is just lambda X divided by lambda L, all multiplied by G. The lambdas can cancel, which would mean that the acceleration of the chain is equal to X divided by L, all multiplied by G. Now, dimensionally, we have to check to see if we are correct in terms of units. The units of X is the meter, the unit of L is the meter, so meter cancels, and therefore the unit of A is equal to the unit of the acceleration due to gravity. So the equation is dimensionally correct. And if this is true, this would mean that the tension in the string, which is just equal to M prime of A, will be equal to lambda bracket L minus X multiplied by A, which is XLG. So right here, we have the tension in the string. We can simplify this, or we can leave it the way it is. So this is really a very beautiful problem which deals with the application of Newton's second law for a chain sliding on a table. I have actually asked this question in a couple of my final examinations in the past, so my recommendation for you is that you should review this problem over and over again. If you have any question, please do not hesitate to ask in the discussion forum below. Thank you, and remain blessed. Bye-bye.